Good morning, my lovely Atlantis Scalar peeps. I would like to share with you today some additions I am making to the weight optimization scalar service. I already work on leptin and receptors and cortisol and insulin response to carbohydrates and a whole bunch of other things related to the physiology behind weight gain. Uh, I have also added two things. Of course, I make sure that the appetite is not triggered by emotions, that the appetite is, normal, is ideal. There are two hormones, ghrelin, Grelin, and leptin, which we just talked about, that control appetite and the sense of fullness or satiety. And they're involved in these vast networks of pathways that regulate body weight, right? So leptin, it decreases appetite while ghrelin increases it. Ghrelin is made in your stomach and it signals your brain, I'm hungry. Okay. So we want to make sure that we tackle that. And here are the pathways. Just kidding. There'll be a pop quiz in a minute. So, I've definitely put that those should be ideal, minimum in the case of ghrelin, if you're overweight, of course, and maximum in the case of leptin. So, but also in Harvard, they just found a new receptor that is in brown fat cells. It's quite interesting. Brown adipocytes derived from progenitors expressing the TRPV1 receptor. They're labeled as in green fluorescent here, right? You see that? This is from Harvard. They're found in adipose tissue, basically. And it's going to read you some of the important parts and why I think this is so important to include in the script now. A new source of energy expending brown fat cells has been uncovered by Harvard Medical School. The research at the Joslin Diabetes Center, which they said points toward potentially new therapeutic options for obesity. They published this in this paper called Nature, this journal called Nature Metabolism. The key lies in the expression of a receptor called TRPV1. TRPV1, yes, a protein known to sense noxious stimuli, including pain and temperature. Okay. All right, so specifically, the authors point to smooth muscle cells that express this. What it really spells out is temperature sensitive ion channel transient receptor potential cation subfamily V member 1 receptor. That's easier to say, TRPV1. Okay, and identify them as a novel source of energy burning brown fat cells, adipocytes. So look, brown and I do say a lot about in the script, in the weight optimization, I do target brown fat and try to increase and activate, etc. Now, this activates in response to cold temperature in order to produce heat to maintain the body temperature, and then it burns calories. Okay, so that's the big key. And so, basically, this opens up potentially new targets for therapy that would get around the use of cold temperature that are used to try to treat obesity. You guys ever heard of Cold Sculpt, right? There's these places you can go and they use extremely cold temperatures to get rid of your fat. I don't know if it really works or not, but anyway, so this is, it's easy for me to just have this receptor proliferate and activate. So and be the right distribution and maximum level of activity, etc. So, and I have an entire page in the script just devoted to this cool receptor. Okay, so TRPV1 positive smooth muscle cells gives rise to brown energy burning version of fat cells, especially when exposed to cold temperature. Additional experiments also show that these TRPV1 positive cells were a source for beige fat cells that appear in response to cold in white fat. So there's all sorts of kinds of fat: yellow, adipose tissue, white, beige. I didn't know about that, and brown. And We believe in fat cell diversity, people. So anyway, the whole thing is brown adipose tissue is just a major thermogenic organ in the body, right? And increasing brown fat, thermogenesis, and general energy expenditure is going to be a very novel approach eventually to treating obesity. Well, we're going to circumvent the weight, and we're going to do this now. So the TRPV1 has a role in detecting multiple noxious stimuli, including capsaicin. You know, some people say that if you eat enough like ghost chilies, you know, it causes you to lose weight because it activates the TRPV1 receptor. Well, you would have an ulcer before you could get enough in there to do that. So capsaicin is a potent agonist for the TRPV1 calcium channel. It's known, probably best known as the molecular integrator of noxious or painful stimuli. Now, this is in something called circulation research. Be skinny on that receptor. So what I'm trying to tell you is I do a lot of research all the time, and I keep adding to your scripts for the Scalar services and try to make it better and better. See, red pepper consumption was shown to increase energy expenditure and lipid oxidation, as well as decrease appetite. And so that's where this receptor comes in. Activation of the TRPV1 channel by capsaicin leads to an increase in cytosolic calcium, increased cytosolic in the cytosol, the inside of the cells. Calcium prevents the early phases of fat production. And I can go into the real big details. This is super complicated. See, this is stopping fat making fat happen, which we don't want. Well, if you're too skinny, you want that. So anyway, that's it. I just want you to be aware of there's a lot more than just me in the Scalar shed working for hours and hours on your services. I am always doing hours and hours of research in my spare time to make things better and better for you. So take a look at AtlantisScalar.com and watch subscribe to this channel so you can find out the new stuff we're doing all the time, new videos that come out. And also, I want to remind you that I'm not going to send as many newsletters because I just feel like I was just spamming your inbox again. So, but we're going to use constant contact to give only the important stuff. Like we got this sale that's going to expire here, or something important. And I'll use these videos to relay information like this and read you your bedtime stories, which I'm not going to do today. All right. I love you guys and have a wonderful, wonderful week. I am leaving for Norway in a couple of days. I sure do need it. I really need it. Thank you for understanding.